The purpose of this video is to demonstrate how to solve absolute value equations. You also could have absolute value inequalities, and those are handled in a separate video. So first, what is an absolute value equation? Well, number one, as the example towards the bottom of the screen shows, it's an equation. And typically we're asked to go solve these, which means we want to solve it for the variable that shows up. In this case, it's an x. But what makes this an absolute value equation is that you see that we have absolute value bars, and the variable that we're hoping to solve for is inside of those absolute value bars. The variable could show up in other places as well if it's in more than one location, but it needs to be definitely inside these absolute value bars, and that's how we classify it as an absolute value equation. Solving these definitely follows a step-by-step process, which I have outlined here. So I'm going to walk through this pretty quickly and then just jump into some examples. I've tried to select a variety of examples that kind of highlight the different types of things that can happen when you're solving these types of equations. So number one, we need to make sure that we isolate the absolute value. That means we want to see that part of the equation or the expression all by itself on one side of the equal sign. Once we do that, we then can ask ourselves, what is that absolute value expression set equal to? What it's set equal to could be a variety of things. But importantly, if it's set equal to 0 or something positive, or something that has a variable expression in it. For example, if that variable showed up in other places. If it's one of those cases, we're going to go ahead and go solve the equation. However, sometimes when we isolate the absolute value, it could be set equal to something negative. And if that's the case, we actually do nothing. There's no solution to those types of equations, which this is the piece right here that differentiates what you do when you are solving an equation versus an inequality with absolute values. They're handled slightly differently. But let's say that once we isolate it, it is set equal to either 0, something positive, or a variable expression, and we decide to go solve that. We solve it by splitting it into two different equations. One we will handle the positive case, and the other one handles the negative case, and you'll see what is meant by that in the examples. And then finally, and importantly, is once you solve those equations and get some potential solutions, at this point they're just potential solutions because you do need to go back and plug them into the original problem and verify that they work. Sometimes they work, sometimes they don't, so you always need to do that piece to wrap up the problem. The one thing I want to point out here with this example again is this very first step is really important. It says you have to isolate the absolute value, and this is an example of a problem where it's not isolated, because you can see the equal sign here, and here's the absolute value expression. That's the absolute value of x minus 4. It is not all by itself on one side of the equal sign. This negative 16 is in my way, if you will. So step one means you have to isolate. So I just want to show you what that can look like. Since this is a negative 16, I'm going to add positive 16 to both sides. And so really, this turns into the absolute value of x minus 4 equals 12. So this is the problem that I would actually go solve. It's important not only do you isolate it because A, it's the right thing to do, but B, somebody that failed to do that at first, they may think that they have an absolute value equation set equal to something negative, and they may think they fall into this category and say you have no solution, but that is not the case. You do not do this step until you've completed step one. So by completing this, we can see this is actually positive, so I would go work this problem and split it into two different equations, okay, as we'll see in the next couple of examples. Okay, so first of all, just some basics. What does it mean to have the absolute value? So these are absolute value bars, and what that means is whatever's inside of here, the absolute value says we want to take the positive case of that. So the absolute value of negative 2 would be a positive 2. This next one, we have a positive 6 in here, and so taking the absolute value of positive 6 doesn't change that. It still stays positive 6. The question becomes, which is at the heart of solving these absolute value equations, how do you handle it when it's a variable in there? What would you do if you have the absolute value of x equals some number? How do we handle these two different cases? And this will be the purpose of this video. So because, let me highlight this, the absolute value of negative 2 is 2, but if I had had the absolute value of a positive 2, it would also be 2. So both of these result in the same output over here. So what that means, if you think about it conceptually, if I ask myself the absolute value of what could be a positive 4, hopefully some of you are realizing, well, it could have been a negative 4, or it could have been a positive 4. It could have been either one of those. And this is at the heart of why, when we are trying to solve an absolute value equation, when this is either 0 or positive or an absolute or an algebraic expression, we actually need to split it into two cases. We need to consider the case as if this had been negative and the case as if this had been positive. So that's kind of the background behind why we split it up. Okay, so if we follow that step-by-step process to get through a couple of examples. So number one, it said isolate the absolute value. So this is already isolated. The second step said, now ask yourself, is this, positive, negative, 0, or a variable expression? This is negative. It's a negative 3. And that's the case that we highlighted. When you have the absolute value set equal to a negative, there's no solution. So we don't even need to progress any further. There is no solution to this problem. And sometimes you'll see people kind of give the empty set as a response to that as well. So no solution. Letter B, however, this really illustrates the case I already did above. If we follow the steps, the absolute value is already isolated, and this is positive, which means I'm going to split it up into two different problems to go solve. So I'm going to have problem number 1 and problem number 2. So how do we do this? We want to consider both the positive case and we want to consider the negative case. There's two different ways to do this. This is the way that I prefer to do it. I take whatever's written inside those absolute value bars and I rewrite it with an equal sign in both cases. And then for the positive case, I set it equal to the positive version of this. So that's going to be a +4. And for the negative case, I set it equal to the negative version of that. So again, take whatever's inside the absolute value bars, write it down twice, and say that equals positive case, negative case. And then if there's some algebra left to do here in order to solve, you would go do that. This was a very simple example, so there isn't. So these are the two answers that I came up with. X equals a +4 and x equals a -4. When you have the positive case, you do not need to put the plus sign. Obviously, it's implied that it's positive. I just did that for emphasis. Okay, now the last step says you should go check your answers and make sure that they really do work. This one is so simple, we kind of already know that they work. But if you take a +4 and stick it in there for the x, and then evaluate that, do you get +4? And I say, yes, I do. So this answer would be valid. And the same thing happens when you put in a -4. When you take the absolute value of -4, you get +4. These checks get a little bit more complicated if the original problem is a little more complicated, and you'll see an example of that on the next page. Okay, so just making these a little bit more complicated as we go. Here is another example of absolute value problem. The variables inside absolute value bars. Step 1, is this isolated? Yes, it is. I have absolute value set equal to something. Step 2, is this thing, positive, 0, or a variable expression? If it is, we're going to go work the problem. And this is, it's a +7, so that says I should go work it. But if, for example, if I had a negative sign in front right there, that would have been similar to the example above, and I would say, nope, I'm not going to do that. Answer is no solution. We're going to go work this one. So I'm going to get ready to have my two different scenarios. So what I said before, let's take what's inside those absolute value bars. Let's write that down twice with the equal sign. The first time we're going to set it equal to the positive version of this, which is a +7. The second time we'll set it equal to the negative version, which is -7. And now these are two separate equations that I need to go solve. These are linear equations, which means we have x to the first power. They're fairly simple. When you have a linear equation, remember, you want to isolate that. You want to get all of your x's combined together. In this case, they already are. And then get the x's on one side of the equation and the coefficients on the other, and then you'll probably end up multiplying or dividing to finish the algebra problem. In this case, I'm going to subtract 3 from both sides. That gives me 4x equals 4. And then to isolate that variable, I would divide by 4 both sides. So I get, in this case, x equals 1. To come to the second option, again, I'm subtracting 3 from both sides. That will give me 4x equals, that looks like it's a negative 10, negative 7 minus, or negative 7 plus a negative 3. And then if I divide both sides by 4, I would get x equals negative 10 fourths, which I will reduce. If you ever have a fraction that reduces, that's considered best practice. So I get negative 5 halves. So these are the two options that I have for answers. Now again, best practice says that we need to take each of those one at a time and go check them to make sure that they work. So I'll put this over here. We're going to check. So first, how about we try x equals 1? That means we're going to take the 1 and put it in right here and evaluate this expression and see if we get 7. And hopefully you can see this one's pretty clean. If you put a 1 right there, 4 times 1 is 4. 4 plus 3 is 7. And the absolute value of 7, that does equal 7. So this one checks pretty cleanly. Let's do the second one, and I'll actually write that one out. X equals negative 5 halves. So that says to take this value and put it in there and see what happens. So that tells me I have 4 times a negative 5 halves, and I need to add that to 3. And then once I do that, if I take that absolute value, does that equal 7? So here, 4 times negative 5 halves, you may be able to tell that that's a negative 10. You could divide this 2 into the 4, and so really you have 2 times negative 5, that's negative 10. And negative 10 plus 3, that's negative 7. If you wanted to do this in a calculator, you could do that as well. But the most important thing is that we then realize that taking the absolute value of negative 7 results in a positive 7. So yes, 7 equals 7, and this answer checks as well. So I would indicate both of these would satisfy this equation. Okay, so let's get a little bit more complicated. One of the things that I mentioned in the step process is once you isolate that absolute value, everything we've done so far, we had our absolute value expression equal to either a positive number or a negative number, but it can also be set equal to a variable expression, and sometimes it can be set equal to 0 actually. So these are the two cases I want to look at the next two examples on quickly. So what do we do if our absolute value is set equal to 0, or if it's set equal to a variable expression? Well, most importantly, realize it's in the section that says we are going to go work those problems by splitting them into two potentially. So let's look at what happens with the case of 0. I have the absolute value of something set equal to 0. So we would go work this, but what I want to point out is as you get ready to split it into two separate equations, take what's inside the absolute value, write it down twice, and the first time you set it equal to the positive version of that, the second time equal to the negative version of that. Well, positive 0 and negative 0, those are both 0. So really, when you have an absolute value that's been isolated set equal to 0, you really only end up with the one case because both of those scenarios are the exact same thing. So the key on these is there's really only one equation that you would go work. And so if we finish this one right here, this is a quadratic because I have an x squared, and the process for solving those would say that you can get everything on one side and try to factor it. You could use a quadratic formula, etc. This one's fairly simple because there's no x term, and so we could actually use the square root property on this one. And what that means is take the coefficient and actually move it to the other side and then just square root both sides. It's a pretty clean way to solve a quadratic if there's a middle term that isn't there. So if I add 4 to both sides, I actually get x squared equals 4, and then square root both sides. The square root of x squared is just x. The square root of 4, though, remember, is plus or minus 2. So these are two different answers that I would then need to go check. So I will check x equals 2, and I will check x equals negative 2. One at a time, plug them back into the original and see if it works. And sure enough, hopefully you can see this pretty cleanly. If we plug a 2 in there, if you square 2, 2 times 2 is 4, we end up with 4 minus 4 is 0, and you do end up with the absolute value of 0 does equal 0, and that one works. And then similarly on the negative 2, just be really careful when you plug in a negative into a square. What that really looks like is this. Protect that negative sign with parentheses, so you don't mess up your sign. And a negative 2 squared, again, that's a positive 4. So we end up with 4 minus 4, and again, we have the absolute value of 0. Does that equal 0? And indeed it does. So we would have both of those as answers to satisfy that equation. Okay, what I want to highlight here is this is a great example of an absolute value equation because we do have variable term inside absolute value bars, but we also have variable term elsewhere, and that's okay. The key is to remember to follow the process. You need to have the absolute value portion isolated and everything else on the other side of the equation. So for example, if this had been a minus 3x over here, I would have needed to move it over first. The way it's been given to you, it's already isolated. These sometimes just visually seem to stump students, but you have to remember, just follow the process and it will lead you to the correct answers once you remember to check them at the end. So what that process says again is isolate your absolute value, yes. Then you want to take what's inside, and we're going to create two different equations out of this to go solve because we have the case that we have our absolute value set equal to an algebraic expression. And so case 1, we're going to write x squared plus 6x equals, and then case 2, again, x squared plus 6x equals, and this is where you want to be careful. Case 1, we're going to do the positive version of this, okay? So think about it as the positive version of this entire expression, okay? Which is why I put parentheses around there to protect it. And case 2, thinking about it as the negative version of that entire expression. So again, the parentheses just emphasize that you're getting both of these cases of the entire expression. In particular, in the negative case, that helps us just be really careful. We're going to need to distribute that negative sign to finish that problem. So this first one actually is x squared. Let me just write these out a little cleaner. X squared plus 6x. The positive version of that is obviously just 3x plus 18. And this one, we have x squared plus 6x equals. If I distribute and push this negative sign through, think about it as distributing a negative 1 through, I actually get negative 3x and then minus 18. These are both quadratic equations because we see an x squared, which is the highest power. And remember, when you solve a quadratic equation, you want everything on one side of the equal sign and set it equal to 0. And then you can determine based on that quadratic that you have how you want to solve it. Do you want to try to factor it? Do you want to complete the square? Do you want to use quadratic formula? You've got some options. The key is let's get it written in its quadratic form first. As I said, the one above, that was the exception because there was no middle term. There was no x term. We just had the square and the number, and that's when you can do this square root property. These are full quadratics with x squareds and x's and numbers. So we're going to do the full method. So I need to move these two terms over. So I'm going to subtract 3x and subtract 18. And when I do that, I'll write that in. By subtracting 3x from both sides, I actually have a minus 3x right here. So I will get x squared plus 3x, and then I also have the minus 18. Sorry, that's a little crowded. But this is the quadratic that I need to go solve here. And then likewise over here, I'm going to add the 3x and add the 18. So if I do that to both sides, I end up with the quadratic x squared, if I combine those similar terms, plus 9x and plus 18 equals 0. And so these are your two quadratic equations that we are going to go and solve. When we look at these, I believe that both of these factor. So if you're good at factoring, you could use that method. If you're not, you may want to go plug these in the quadratic formula. If you're not sure how to do that, there's a separate video that highlights that. But I see that these both factor. So for me, I'm going to choose to do them that way. So I have x, and two numbers that multiply to get negative 18, but add to get 3, a 6 and 3. So a 6 and a 3. If I make the 6 positive and the 3 negative, that gets me the negative 18, and combining those gets me the plus 3x. So once you have a quadratic factored, if you choose to use that method, zero product property says we can take these one at a time and set them equal to 0. So x plus 6 equals 0 will give me an answer, and x minus 3 equals 0 will give me another answer. So if I set those up separately, this one results in x equals -6. This one results in x equals 3. So far, here's two of my options. Remember, we need to check these when we're done to see if they actually work or not. Here, factoring, again, I'm going to do this quickly. It says, again, it's a 6 times 3 multiplies to 18, and they add to get a 9 because that's positive and that's positive. So this actually factors like x plus 6 and x plus 3. Again, if you're not sure how to do this, you could choose to use the quadratic formula, or you could go back and watch the factoring video on factoring trinomials to be able to do that. So following the same thought with zero product properties, setting these equal to 0 one at a time and solving, we see that we get x equals -6 and x equals -3. So what I want to point out here is that we got two answers from this quadratic and two from this. There was a duplicate, however, and that's okay. It really means there's only three things we need to check. So these just became our options. X could be -6, -3, or 3. So this is what's in my potential pool. Now I need to go check these one at a time. So I can take the -6, I'm going to put it here and here and here and see, is this a true statement, and then I will follow up with both of the others. I'll show you how to do one of those checks, and then you can do the others on your own. When you do each of these three, they all do indeed work. Let's just try the -6. So if I were to check that, I would say I want to take a -6 and put it right there. So I need to take the absolute value of -6 squared plus 6 times -6, the absolute value of all of that. Does that equal 3 times -6 plus 18? So let's see what happens. So inside the absolute value bars, -6 times -6, that is 36. And this is 6 times -6, that's -36. Does that equal 3 times -6 is -18 plus 18? So in here, inside the absolute values, that's going to be 0. And the absolute value of 0 is 0. Does that equal? And sure enough, that is also 0. So that would check out. And again, if you did that same process by plugging in these two, you'd find that they work as well. So we would circle all of these as acceptable answers to that absolute value equation problem. One last thing I want to point out is sometimes when you plug answers in, they don't work, and then you cross them off. So here's an example of that. Here's another absolute value problem, similar to the one that we just did, because we see the variable not only in the absolute value but outside as well. So we would break this up into two problems. You can see I've already taken the x plus 1 and written it down twice. The first time I set it equal to the positive version of that expression, and the second time it was equal to the negative version of that expression. And then these, again, both result in quadratics. So when you go solve these quadratics, you do end up with 4 distinct answers. These two actually result in whole numbers. These two actually result in irrational, which is fine. Then you need to go check all 4 of them to see, do they or do they not work. I want to show you an example of what happens when it doesn't work. So one of the solutions that comes out of this quadratic right here is actually x equals -2. And so let's go check that so I can show you what happens. So as I prepare to stick that -2 in, notice, so I've left room. I need to put the -2 right there. It's because it's x plus 1, the absolute value of that. Does that equal -2 squared minus 5? So let's look at what happens. -2 plus 1, that is -1. A little question mark there. And what happens over here, -2 times -2, that's 4. So I have 4 minus 5. And look at what happens. The absolute value of -1, that's a positive 1. And what happens over here, that's 4 minus 5. That is -1. That is not the same thing. And sometimes this happens. And what that means is when we had our potential answers that popped out of these two different equations, we would have to cross this off and say that it doesn't work. Now, what can happen is when you have a list of potential answers, sometimes like in that previous example that I did, they all worked. You could have all of your potential answers, none of them work. You check every one and they all fail, in which case you would say there's no solution. You could have an example like you end up with in this problem that some of them work and some of them don't. So just again, remember when you're doing these absolute value equations, it's a process, step by step. You need to isolate the absolute value first, then see which case you have. And if you have this case above, you need to split it into two different equations, both the positive and negative cases. And then most importantly, don't forget to check your answers when you're done, so you can get all of those problems correct.